Limits as you approach infinity. So if we're dealing with rational expressions, there's three results that could occur. So let's say limits as you approach infinity. For instance, let's go for x squared plus 4 over 2x squared minus 5x. And the quick rule that you might have learned from pre-calc is it's the same thing as asking for horizontal asymptotes. If the powers are the same, it's the ratio of the coefficients of those highest powers. So the answer is going to be 1/2. However, to show your work, you're supposed to go ahead and divide every single term by the highest power of the denominator. That's the rule. So what I mean in this case is, to show your work, you're actually going to go ahead and take this same expression here and multiply the numerator and the denominator by 1 over x squared, and then distribute that. So if you do so, you're going to get 1 plus 4 over x squared divided by 2 minus 5 over x. Because technically, infinity over infinity is an indeterminate form. Like if I plug in right now, the top will go to infinity, the bottom will go to infinity, and that's indeterminate. So to determine this, we have to go ahead and write it in such a way where when we plug in infinity, we know any finite number over an infinite number will approach 0. And so that's why we get 1/2 for the answer. So the first rule is if the powers are the same on the top and bottom, it's the ratio of those coefficients of those dominant terms. If the bottom happens to be bigger, well, then it approaches 0. Same idea here. You multiply by the highest power of the denominator. And in this case, you get x over 1 plus 4 over x squared, limit as x goes to infinity. And in this case, it doesn't matter if it's plus or minus infinity. It can be plus or minus, plus or minus, plus. It doesn't matter here. Ultimately, what's going to happen is that goes to 0. You get 0 over 1, which goes to 0. Where it does matter is when the numerator, the top, is bigger. If I gave you the limit as x goes to infinity, and let's do both, the limit as x goes to negative infinity of, let's say, 5x cubed over x squared plus 1. So 5x cubed over x squared plus 1. Well, again, if I multiply by 1 over x squared, because I'm doing the highest power of the denominator, okay, 1 over x squared, 1 over x squared, highest power of the denominator, I will get as a result a need to move that equal to sign over. Let's get that moved over. But I'll also go ahead and get 5x on top, 1 plus 1 over x squared on bottom. Okay, while this goes to 0 and this goes to 0, the top, though, 5 times infinity will approach infinity. 5 times negative infinity will approach negative infinity. So the signs will matter when the top is bigger. And going backwards now, if you were asked for horizontal asymptotes, you would evaluate the limit as you approach infinity and negative infinity. In this case, there is no horizontal asymptote. In the previous page, the horizontal asymptote would have been y equals 0 for the bottom problem, and on top it would have been y equals 1/2. And that's if they were to ask just what is the horizontal asymptote after evaluating the limit as you approach plus or minus infinity for a rational expression.